Good morning. You're welcome to class today. I'm so excited to see you once again. I know it's been a while you see me on your screen. New lessons coming back. So I'm not listening to music. We're about to get into solution to practical problems in bearing and distance. Remember to get your pen, your writing material, and your textbook. Okay? Because we're going to be solving questions from your test. Don't forget that at any point in time, if you need to, you can pause the video so that you can follow through the steps. And also, if there's any point you think you've missed or you really need to think about, you can also still rewind to catch up and do that. So don't rush through the lesson, take advantage of the video, and then the important thing is that you go through all and get this concept tightly. Okay, let's get into the lesson. To be able to solve practical problems, you need to know how to take bearing. So we look at taking bearing last week. Let's just revise what we looked at before. If you're taking the bearing of x from y, you focus on y because that's where you're taking bearing from, and measure the angle that is formed from the north of y to the point where it meets with x. Okay. Similarly, if you're taking the bearing of y from x, focus on x and measure the angle from the north of s to the point where it meets with y. Okay, in this case, you can see if you go from the north of S and come all the way, we would have make a full turn, but then this is where it meets with Y, and the angle over here is the alternate angle of X here, which is determined as 24. Subtract that from 360 to get the bearing of Y from X. Okay, know this before. I just have to touch it again. Now let's look at the practical question. A man leaves his house and travels 21 kilometers on a bearing of 32 degrees and then 45 kilometers and a bearing of 27. So the secret of solving this question is being able to represent this bearing on the board. Okay, so you get a note and try to draw the bearing of the man on 32 degrees and then 45. So I'll go to the board and then we'll see what we can do. Come with me to the board. See here, if you get the first bearing, you went 32 degrees from and then 45 kilometer and a bearing of 287. So the bearing of 32 degrees is from the north, and then from here to here is 32. So we went 21 kilometer. Okay, so we can this side is 21, and then we went 45 kilometer and a bearing of 287. The bearing of 287 from here, let's call this particular place a stop here, and then 287. We have to start from the north again from here and come all the way to this point. That will be 270. Okay, so that means plus 17 here because 270 take away from 27 is 17. So we went all the way from here and move 45 kilometers this way. Okay, okay, so it's important that you get this diagram correctly. This is the first bearing of 32 degrees from here to this point. And then when you're drawing angles, you should also be careful to know that this angle is going to be alternate to this angle. Okay, it's alternate to this angle. That means if that's 32, this also is 32. So we can then find this as 90 minus 32. Okay, but this angle I already said will be 17 because we to start from the north of the stop, call this place the stop, we go all the way this way to this point is 270. So that's 3/4 plus 17. So this is 17 already. So just leave it this 17 and this as 90 minus 32. Okay, so let's call this place where he stops the final stop. That's his F. You can call this place F. So you said the question is to find the firstly we should calculate the distance between the man's final position and his house. So that means you have to connect his final position to his house. So we come all the way here. That gives a triangle. Okay, note that this is a yes, that gives a triangle. But then what we have from the triangle is that we have this angle 38, 32. But then there's another angle here. But if you add 17 plus 58, which is the complement of 32 here. Okay, we have what we call the a total of 75 degree. That's the angle we have here. So the triangle we have here has two sides and an included angle. So I'd like you to tell me what solution to triangle can we use? We've learned Pythagoras theorem before. We know how to use the Pythagoras theorem, the trigonometrical ratios, the SOHCAHTOA. Then we learned the sine rule and the cosine rule in the past place. So which of all of these ways of solving triangles is applicable here? Because we have two sides and an included angle. Can we use the sine rule? I'd like you to pause and think about it. Yeah, best you found out that the rule that we can use is the cosine formula. The cosine rule is one we can use because we have this angle. So we have on two sides. So the sine formula would not be applicable because we only have the other side, and we can have we have only one angle, and the side which we are to determine is the small s. So if we label this appropriately, this will be the small s, but this is a big S as a stop, and then this side is the small h. Okay, and then we have the f. So yeah, so if we do s but s, we don't have any other angle, we have only one angle. So use sine formula, we need at least two angles to the side. So write out the cosine formula using this side quickly. Okay, so this is what it's going to look like. You have h squared plus f squared minus 2hf plus s. So we have to determine s. We have angle s, we have everything. So put all of this into the formula and calculate for s. Okay, using your pen and paper quickly. So you can pause the video, put that into the formula and calculate for s. Okay, so putting the different given side into the formula, so cosine formula, you get that s is finally going to be equal to 44.5 kilometers because you get 5 squared plus 21 squared, you get this, and then minus 2 times 45 times 21 gives this for 75 degrees using a calculator. I'm sure you get that. That's 44.5 kilometers. So this side, which is the distance from his final position to his house, is 44.5 kilometers. The next way to find is the bearing of the mass house from its final position. So this is its final position. From its final position, so we are coming from here, north of this place to this particular point. So take note and be careful that from this place to this point is 90, and here is going to be equal to this point also. They are alternate angles. Whenever you take bearing, just take note that this angle here to this here is they are alternate. So that's 90 plus 17. Then the remaining part of the angle we need to find is here. Okay, we need to find this angle here in this the triangle. And to find that, we can see use cosine formula because we already know this angle, right? And this angle are in a triangle. So the angle in the triangle here, you can find it using the cosine formula. So we just change the formula to find that. So we write the cosine formula to find the missing angle. Can you do that? Let's get to it. So it's going to be like this. Cos f, as the angle here, is equals to h squared plus s squared minus f squared over 2hf. Okay, so if you pause the video, put the values into the formula and solve for f quickly. Yeah, sorry for that. So putting that into the formula, we have cos f equals to this. When you solve correctly with your calculator, you get f equals to 27.1 degree. Trying to type that in. Okay, so then you have this angle, which is 27.1 degree plus 17 plus 90. That gives us the bearing of from his final position to his house. Okay, that's how to apply true bearings to practical problems. Try out any two questions on page 183 of a textbook. Any two questions on page 183, exercise 80.5. Any two questions and post to the class channel before the next class. I'll catch you. Bye.